Thanks everyone for joining the last talk of the day, I think, or drinks, beverages, beers, whatever you prefer. Hopefully this won't be boring and hopefully we won't presentation. The title of the talk is The Evolution of Stack Validation, Progress and Insights. Maybe a personal reflection before I start with the agenda and so on, and then I ask Chris to introduce himself. I joined a bit less than a year ago to SUSE, April 1st, and some of you might have been to SUSECON 2024. It's about like 10 months since SUSECON 2024, and I was really stressed when I was presenting stack validation at that time because the framework was very young, the edge itself was very young. We made our first release around April, May, and many things weren't in place. But today, when Atanas asked me how I am feeling much better, but a bit depressed because the amount of the work ahead of us when it comes to validating the SUSE Edge product and its scenarios. So this talk is about our progress with the stack validation, where we were last year and where we are now, and where we will be hopefully in coming months. And my colleague Chris will help with the talk, and he will do a cool demo. So who we are? Maybe Chris, you can go.
Yeah. My name is Cristian Geraskov, and I'm Senior Edge Container Engineer, and joined SUSE 2 years ago, I think, and working on different Edge products, and one of them is the stack validation.
Thanks, Chris. And as you see, my name is Fatih Ermenci, and as already mentioned, I joined a bit less than a year ago, working with stack validation since I joined, and working on what SUSE Edge. So what we'll talk today, we'll start with overview of SUSE Edge Stack, and the diagrams we'll show, you probably have seen them during other talks. I think this is the 4th or 5th Edge talk today, and obviously we all use the same diagrams for talking about the stack itself. And then we will talk about validating SUSE Edge Stack, what we are doing there, and what is the point of validating SUSE Edge Stack, and what is like the level of complexity we are dealing and we will be dealing with in near and far future. The framework, tooling, infrastructure, because it is important to talk about the pieces we have in place for the framework and the tools we are using for it. We will talk about some example scenarios, how we are running them. Chris will do a demo demonstrating one of the scenarios we are validating in stack validation. We will speculate a bit about the future, what we are working at the moment, and what we'll be working in coming weeks and months. And finally, some time for question and answers, hopefully in the end. So SUSE Edge Stack. Again, this is one of the diagrams you probably have seen before. Zero-touch provisioning. And if you went to other talks, you probably learned about the 3 different ways of provisioning mechanism we support in SUSE Edge. And the first one is direct network provisioning, which is generally used by telco industry, and it's simply provisioning the Kubernetes clusters on known set of hardware using MetalCube and Cluster API. And as it says, zero-touch provisioning, you basically use declarative approach to manage your downstream clusters. The second one is phone network provisioning. Again, it's another zero-touch provisioning mechanism. Again, this is mostly non-telco type of environments, remote devices that are in unknown environment, and maybe with low, bandwidth and intermittent connectivity, you send your device there, install it, and then that device calls home. We use Elemental Edge Builder for that. And image-based provisioning, I think there was an Edge Image Builder demo a few hours ago. We use Edge Image Builder to create images and provision our management clusters, for example. And this is coming from, this is part of SUSE Edge Stack, and we have to validate all these different types of provisioning mechanisms in stack validation. So in addition to the provisioning mechanisms, we also have like management and runtime stack management clusters. We need to bring up management clusters with Rancher, RK2 on different types of environments, virtual machines or bare metal machines, with different types of SUSE solutions like SUSE Security Storage. That is part of our management cluster, and we have to pick and choose which components, which SUSE technologies, or which open source technologies we are including in our management clusters. On the other side, we have the downstream cluster or runtime stack, and we deploy them on bare metal nodes or virtual machines. And similarly, we put SL Micro on top of it, and we put Kubernetes on top of it, in addition to other SUSE or open source solutions. Again, they try to show as many different solutions, technologies as together, but depending on the scenario we are validating, sometimes only just RK2 could be installed on downstream cluster, or sometimes more components could be installed on the cluster, and we determine what to put on our clusters based on industry and custom use cases. So when it comes to validation, I was saying we are not randomly putting things together in SUSE Edge Stack Validation. Our purpose with stack validation is to make sure that we validate most commonly used scenarios or most use cases get from our customers. We compose those scenarios in our environment, and we validate to ensure we can catch issues or we release our products so our customers don't face with those issues. And it says in the first point, our scenarios are modeled after real life use cases. Again, that is the key thing. And the other thing I want to highlight here is the Edge Stack is treated as a solution. We don't go too deep in validating individual components because we consume those components. For example, BCL, we get SUSE Linux Micro from there, we get Rancher and RK2 from Enterprise Control Management team or unit in SUSE, and they do awesome job there validating those individual pieces. What is really critical for us is actually treating the deployments or the scenarios as solutions, and we extend their validation efforts by introducing our own validation and testing things, validating things like a solution as an integrated stack. So that is the, I think, value we are adding to SUSE and for our customers. And finally, not just validating the integrated stuff, but integrating things is a different challenge. And this framework helps us during integration phase as well, not just the integrated stack, but when we bring in new component or when we bump versions of different things, stack validation helps us to make sure if we can move to Kubernetes 1.32, for example. And the first thing we see there, okay, Kubernetes 1.32 doesn't work because we don't have the Rancher 2.11 there, because Rancher 2.10 supports Kubernetes 1.31. So it helps with our own integration efforts as well, just validating SUSE Edge Stack from customer perspective. So this is a very high-level table. When I started talking, I said I feel a bit depressed. Number of scenarios or our test matrix is growing significantly. When I was talking about stack validation June 2024, last year, right after we made our first release, 3.0 release, I believe we had 3 scenarios or 4 scenarios. Management cluster deployment, downstream clusters deployment using MetalCube and Cluster API, downstream cluster deployments using Elemental. Now the variety of things we are validating and we will start validating has grown a lot, and this will only keep growing. If you were in the roadmap presentation in the morning given by Larry Morris and Tim Ernich, they talked about 3.4 and future. So there are even more things that are coming to our way which we need to validate. But if we quickly look at what kind of variations we are dealing with within stack validation and we will need to deal with. First of all, we have hardware vendors. For example, Dell, HP, and Supermicro. Why I'm highlighting this? Because the Cluster API or MetalCube uses Redfish API, and we have to make sure that the Redfish or MetalCube compatibility is validated. So if our customers ask us, oh, does SUSE Edge Stack work using these hardware from these vendors, we should be able to tell them, yes, we validated this, all the Redfish compatibility validation is done. You can safely put SUSE Edge Stack on any of these vendor hardware. CPU, Intel AMD Ampere, and architecture x86 ARM, network interface Intel Broadcom. Again, this is the hardware dimension of the validation efforts we have. When it comes to software, I'm not going to talk about all of them, but you can see all those things there. And as I mentioned, we don't install or include all these components or configure like real-time kernel versus non-real-time kernel for all our scenarios. Depending on which scenario we are validating, we configure them accordingly. Security, FIPS, again, some scenarios have FIPS enabled, some don't, depending on the scenario we are testing. Networking configuration, again, IPv6, IPv4, dual stack, DHCP, DSP list. Some of these are already in place, some are currently something we are working on. We test different CNIs. We also enable some telco-specific features to make sure we can, validate performance. Topology and availability is another dimension. We might be deploying standalone management clusters. We might be deploying standalone management cluster and downstream clusters. We might be deploying single node. We might be deploying multi-node. And finally, connectivity, air-gapped and online. So it's like all these things. Again, the number of combinations maybe hundreds if you put them randomly together. But it's not fair to say we are testing all 100 combinations. As I said, we are composing the scenarios based on what we learn from our customers, and we focus our efforts around validating those scenarios. And this is a simple tree matrix. Again, this entire picture. There are additional. Again, we are prioritizing some scenarios over the others. For example, telco is priority for SUSE Edge, and we are increasing our efforts around validating telco-specific features, for example, DPDK. And topologies, this is, I already mentioned, it could be a standalone management cluster, it could be management cluster and elemental downstream cluster, or it could be management cluster and copy downstream cluster. And testing. So clusters, it is one thing. I think we can deploy clusters to that. That is not the key thing. What is really important is is the cluster we are putting, is the management cluster or downstream cluster, are they behaving as expected under different conditions? Like we install different applications or SUSE solutions or open source solutions. We go and basic checks there to make sure those basic things work first. Because if some basics don't work, like if pods are not there, not running, our deployments or services available, there is no point proceeding with the next set of tests because the basics are broken. We also deploy some basic application. From there, we do some more stringent testing, like functional testing, creating virtual machines using KubeVirt. For example, one of our scenarios have KubeVirt, and we create VMs to actually validate that customers, when they deploy KubeVirt as part of their SUSE Edge stack, they should be able to create VMs. On top of that, we have some disruptive tests, such as stopping Kubernetes service to see if the cluster stays up and responsive. We also kill nodes to see if the cluster recovers or stays up. We also do some storage tests around Longhorn replicas and so on. Finally, we use Kubernetes conformance suite, and we run conformance tests on them. And again, this is just a subset of what we are doing. And again, just going back to roadmap Tim mentioned in the morning, we have a huge backlog of tests which we are working on integrating into stack validation. And hopefully we will increase our coverage a lot coming period. And the last thing is day 2 operation. There was upgrade controller talk just half an hour ago. So that is something we also test in stack validation, because otherwise we are not covering a key piece of our Edge stack offering. And now I pass the word to Chris.
And infrastructure. This is really top level architecture of stack validation, sorry, and we use open platform where we host Archi2 cluster, and on this cluster we apply cron jobs scheduled daily or nightly, and those cron jobs start stack validation cron jobs and our scenarios. This GitLab is connected to Nürnberg Lab where we host our servers, and we use those servers in two different ways. The first one is by creating virtual machines on top of the bare metal, and we use those VMs as Kubernetes nodes. And the second one is directly using them as bare metals, for example, for copy setup, where we want to run the inspection and then the provisioning directly against the bare metal and to test the hardware. And finally, once the cron job completes,
Just want to add something there. The stack validation results UI was linked on roadmap slice in the morning, and if you checked it, it is completely red at the moment because we are going through some network migration in our lab, which is impacting our CI workloads. Also, we hit Docker Hub rate limitations, which we are working on improving. So if you see it red, it's because we are dealing with some infrastructure issues and hopefully improve soon.
In terms of tooling, as already mentioned, we use GitLab where we store our code, and also we use GitLab CI for our cron jobs and pipelines. Most of the stack validation code base is based on Ansible because Ansible provides us declarative way for combining the different subtasks that form one specific scenario. We will see the scenarios in the next slides. For managing and communicating with the infrastructure, we are using Redfish and SUSE tools. And for testing, for unit tests, we use BATS. And for conformance tests, we use Sonoboy and Next.js for the UI part. Now we will see two of our scenarios. They both consist of 6 subtasks. And the first one is Kiwi-based scenario, where firstly we built SL micro image with Kiwi. Then we use this image for building ISO with HImage builder, and then booting our management cluster machines with this ISO. So now we have management cluster, and we should repeat the steps, but for the downstream elemental cluster. We built SL micro image with Kiwi for the elemental downstream cluster. Then we use this image for building the ISO and then booting the downstream cluster. The second scenario is the copy upgrade scenario. Again, 6 subtasks. The first task is building ISO with HImage builder, booting the management cluster. Then this time we will build raw image because Metal Cube works with raw images, booting the downstream cluster. Then we need to run some tests to see if the cluster is up and running and everything is green, and if yes, then we start upgrading firstly the management cluster with upgrade controller, and then again running some tests to verify if upgrade is successful or not, and then we run the downstream upgrade. It's important here that to consider the scenario as successful, all the tasks, all the subtasks must pass. So this is really critical moment here. And time for the demo. For the demo, we will see the second scenario, which is the copy upgrade, but this scenario normally takes more than 2 hours, and for that reason, to speed the things up, we already deployed the management and the downstream part, and what we will see is just the upgrade and the management and the downstream upgrade, where for the management cluster, we will upgrade the operation system, the Kubernetes, and the Helm charts, and for the downstream, we will upgrade the Kubernetes. It is important to mention that the cluster will be deployed with H3.1.1 version, and we will upgrade it to H3.2. And how the management upgrade happens, we have GitLab CI runner with 3 VMs on top of that runner. we have two different components, upgrade controller and system of upgrade controller, and also three different resources, upgrade plan, and jobs. And what will happen, GitLab will apply an upgrade plan in the cluster. Then UC will take this plan, will create plans, and system upgrade controller will pick up that plans, will spawn jobs, and those jobs will finally upgrade the nodes. And yeah, finally we will verify if the upgrade is successful by checking the upgrade plan and also verifying the node state. For the downstream cluster, a bit different. We have here management and edge part. In the edge part, we have 4 different VMs, 3 control planes, and 1 worker. And for each VM, we have corresponding bare metal host and machine objects in the management part. And also we have RK2 control plane and copy, where RK2 control plane keeps the state of the downstream cluster, like Kubernetes version, OS, and yeah, everything about the downstream cluster. So we will patch the Kubernetes version of in RK2 control plane, and not just the Kubernetes version, but we will also change the rolling upgrade strategy. We will change the max search equals to 0, just to be sure that we will reuse the same VMs during the upgrade. And copy will, we will see this change and we will apply the upgrade to all the VMs. And yeah, we will verify if everything is successful after that. And now it's time for demo. This is our runner, the hypervisor. I hope you can see the screen. We have 7 VMs here, 3 for the management cluster and 4 for the downstream cluster. On the top side, you will see the management cluster, and on the bottom, you will see the downstream. And all the 3 nodes are there with Kubernetes version 1.30.5, which is coming from our H3.1.1 release. And also, we have 4 bare metal hosts and 4 machines deployed on the management side. The machines have the same Kubernetes version 1.30.5. And also RK2 control plane will still have the same Kubernetes version in its spec. On the downstream side, we have 4 nodes, 3 control planes, 1 worker with Kubernetes version 1.30.5. And also we have in our management cluster upgrade controller and system upgrade controller pods that will be used for our upgrade now. In the GitLab UI, we can see now that the management upgrade subtask is started. It is running. And we can check the logs. Currently, what we can see is that it is looping on verify the release manifest is deployed. The release manifest is a resource that keeps everything about one specific H release, like operation system, like Kubernetes version, and all the Helm charts, their version and sources. Here you can see the release manifest for H3.2 version, because that's the version that we want to use for our upgrade. And yeah, the traffic, the core components, the Kubernetes version will be 1.31.3 this time. Yeah, here you can see all the Helm charts, the operating system, which will be used for H3.2. And yeah, all the workloads. And yeah, this is for release version H3.2.0. And the Kubernetes version that we will see later on our nodes will be 1.31.3. We have another resource here, which is called upgrade plan. This is the contract between the users and the upgrade controller, where we just specify that we want to upgrade to H3. In the spec we have release version H3.2.0, and then upgrade controller starts upgrading the cluster and reports back the progress in the conditions of this resource. We can see that the first thing that will happen is OS upgrade, then we will see Kubernetes upgrade, and then all the Helm charts will be upgraded one by one. So the first node is being upgraded right now. It is cordoned, it is drained, so the upgrade is safe. And now we can see that the first node is already upgraded with the new Kubernetes version 1.31.3, and the upgrade will continue with the second and with the third one. In the conditions, we can see that the operation system is already completed, and now we are waiting for Kubernetes upgrade, which is in progress. What we can see now is that the Kubernetes is upgraded. All the nodes are switched to the new Kubernetes version, but this is just for the management cluster. On downstream side, we still have the old one, and in Stack Validation UI, we see green pipeline. So this subtask is successful right now. We can double check the upgrade controller, the upgrade plan, to see if everything is succeeded. Yeah. All the charts are upgraded successfully, and one important thing that we check in our framework is this was successful release version field, which reports if the entire upgrade is successful or not. If we have it, then this means that the upgrade is successful, and we also can see that the pods are upgraded, which is expected because we changed the Helm charts versions. And now our management cluster is upgraded, and we will continue with the downstream now. The job is started. We can see upgrade H metal cube. We can see some logs here. And on the downstream side, the same things will happen. But this time the upgrade will be done by copy. How copy performs upgrades? We will use rolling upgrade strategy. RK2 control plane resources already with the new Kubernetes version. So we will use rolling upgrade strategy where as we have 3 control planes and 1 worker node, firstly the first control plane and the worker node will get upgraded to the new version, and once this is done, the second node and then the third node. This is what is happening right now. So copy doesn't allow in-place upgrades, and what will happen is that the node will be the virtual machine first will be deprovisioned, and then will be provisioned back with the new Kubernetes version. Now we see that the machine objects are being deleted, and yeah, 2 of the machines are already upgraded, and we are waiting for the next 2 now. in a few minutes, what will happen is that all four nodes will be upgraded with the new Kubernetes version, and we will consider the upgrade as successful. Okay, we are provisioning the third machine. And finally, all the four machines are upgraded with the new Kubernetes version 1.31.3. On the top side, you see the machines, and now you see the nodes on the bottom. And in the GitLab UI, you also can see that upgrades is reported as successful. So the entire scenario is successful now because all the subtasks pass successfully. And
Before we move,
one more.
yeah, one more.
And
Okay.
yeah, upcoming work and ideas. Currently, we are working on a telco-enabled clusters, also ARM support, Metal Cube compatibility testing, network performance and RT performance testing, which is essential for the telco clusters. Also IPv6 dual stack support, LFN func test integration, and we are experimenting with prowess CI/CD because we are using different platforms, different tools, and we want somehow to streamline the entire flow. Yeah.
I just added before the presentation, like how all we do, like we finish our slides just a minute before the session. So we just did this. Tomorrow, Nicola and Jiri have a talk about the future of stack validation, and we'll go into different areas like visualization, results UI, and so on, as well as factory workflows. I suggest you to join that session if you want to know what else will be coming. So I think it's beer o'clock. Thanks for joining.